This video is looking at a core 2 differentiation question. So the reason it's in core 2 specifically is because you've got x as a denominational fraction here, which means we've got a negative power of x involved. Other than that, it's very similar to the differentiation questions you'd have had in core 1. So let's just go through it together. Part A says find the y coordinate of P, where we're told that the point P lies on the curve for this function of x equals 2. Just a quick note, it says here the curve is defined for x greater than 0. The reason we've got this extra restriction in the domain is that if we have x equal 0, we have 0 in the denominator fraction. We can't have 2 divided by 0, it's undefined. To find the y coordinate of P, we just need to use the rule. We're given the function y equals 1 plus 2 over x all squared, and we're given that x is 2, so we substitute it in. So we've got 1 plus 2 over x is 2, so 2 over 2 all squared. 2 over 2 is just 1, so it's 1 plus 1 all squared, which is 2 squared, equals 4, which is a straightforward first mark. Part B, expand the brackets. 1 plus 2 over x all squared, that means the same bracket multiplied by itself. So we're just using FOIL or some other sort of system like that. We're going to do 1 times 1, which is 1. The outside bracket is 1 plus 2 over x, this is 2 over x. Inside is 2 over x times 1, which again is 2 over x. And the last one each bracket, 2 over x times 2 over x is a fraction multiplied by another fraction, so we just need to multiply the numerators. 2 times 2 is 4, and the denominator is x times x. That's going to be x squared. We might want to simplify that down just by adding the fractions with the common denominator. So 2 over x plus 2 over x is 4 over x. So done. Part C, find dy by dx. Now, the clue is in the question above. We've already expanded the bracket, so it's in an easier form to deal with already. The other problem we've got though is we've got these x's and the denominators of fractions, which are a bit tricky to deal with these sometimes, so it's much more convenient to write them as negative powers. So I'm going to write my function in terms of negative powers of x rather than as fractions. So I'm going to write it as 1 plus, and rather than 4 over x, I'm going to write 4x to the power negative 1. And similarly, instead of 4 over, I'm going to write it as 4x to the negative 2. Now I can differentiate it a little bit more easily. So 1 is x to the power 0, so that will just go to 0, so just ignore it. Using the same rules we did in core 1, we're going to multiply by the power, so multiply this by negative 1, which will get me negative 4, and reduce the power by 1 will get me x to the negative 2. Similar here, we'll do negative 2 times the 4, so that will be negative 8, reduce the power by 1, to be x to the negative 3. Now I don't specifically need to do it in this part. I think it's nice just to simplify it down a little bit more, rather than write x to the negative 2, switch it back into a fraction over x squared. And do the same thing with this one, so 8 over x cubed. It's not strictly necessary to get, but it just looks a lot nicer and also makes life a little bit easier for dealing with later on in part B. So, part D. Hence, the gradient of the curve at P is negative 2. Well, I've got the gradient function here, dy by dx. I just need to find it at point P, where x is 2. So I just need to find dy dx at that point. I simply substitute it into either equations from above. I'll choose this one. It's a little bit more straightforward than going back into functions. So dy by dx will equal minus 4 over, substituting my value of x in here, 2 squared minus 8 over 2 cubed, which is negative 4 over 2 squared is 4, minus 8 over 2 cubed, which is 4 is 1, 8 over 8 is 1, so it's minus 1, which is minus 2, as I've been given here anyway. And the final question you need to do, E, find the equation of the normal to the curve of P. Now, keep it there is the normal. Watch out for that in exams, because it's easy to slip up on. This is the gradient here, negative 2 of the curve, or the tangent to the normal will be the inverse reciprocal of that. So the gradient is going to be inverse reciprocal of negative 2, which is a half. So to write the equation of the line, I can just use y equals mx plus c, so it's going to be y equals a half x plus c. And then I just need to substitute in a value of y and x that I know. Well, he's given me these earlier on in the question, told me that x was 2 and asked me to find the y coordinate, which I worked out was 4. So I'm just going to use that coordinate there. So I'm going to put in y value which is 4, my x value was 2, so half times 2, which is just 1, plus c, so c must be 3. Here it's y equals half x plus 3, and to complete the question is write it in the format it asked for here, x plus by plus c equals 0. So to do that, I need to get rid of the half because I want b and c to be integers, so I multiply them by 2. 2y equals 1x plus 6, all on the same side, x plus 6.